Okay, my dear participants, today I am going to talk about yes. So we have already covered some portion of ggplot2. Yes, data visualization with ggplot2 using R for data science. R for data science by Helly Wickham et al. Is a great book on tidyverse. In this book, in this video, we are going to cover most of the material from that book only. We can use package tidyverse for the analysis and graphics. So, library gg repel, library Palmer Penguin, and then library gg themes, the required dplyr and glimpse penguin. So, these are the glimpses of penguin data. Here we have already made just AES x is equal to that. So, here there is no GOM point. So, that is why it is only here in this graph we are adding GOM points. So, it adds the points also. Then adding aesthetics and layers. So, here we have added aesthetics and layers. See ggplot data penguins mapping AES x is equal to flipper length in millimeter, y is equal to body mass, color is equal to species plus GOM point. So, here it adds the color is equal to, because of the color is equal to species, these species comes here. It is Adelie and then Chenstrap and then Gento. So, these are the and when we add plus GOM point, GOM smooth data is equal to LM. So, we have these three lines fitted. These parallel line shows that the slope of at the rate of growth in these two species, chin strip, this Adelaide and chin strip is almost same, but here it is sharper growth in terms of Gen 2. So, we have already covered these things. Here see the difference between these commands. Here we have GOM points, within that we have set AES color is equal to species plus GOM points, GOM smooth method is equal to LM. So, here we have in the earlier here we have not set anything in the GOM point, we have not set anything in the GOM point, whereas here we have GOM point mapping is equal to AES color is equal to species. So, it makes a single graph, method is equal to GOM smooth. So, it makes a simple plot of all the observations, there is single plot. So, with color we can represent shape also. So, here we have AES color is equal to species and shape is equal to species. So, it has shapes also, and that is why we have species and see these are the three species, and see in addition we can improve color plate to be color blind safe with the scale color blind function from the GG themes package. So, here these are the shapes, different shapes. So, it is adding species as well as shape. Say for example, this is in round, this is in triangle and this is in square shape. So, all these, so these are the squared. So, it is having shape as well as Now we are going to add, see, in addition we can improve the color plate to be color blind safe with the scale color blind function from the GG themes package. So, ggplot data is equal to penguin mapping AES, x is equal to on x axis flipper length in millimeter, y is equal to body mass in gram plus GOM point AES, color is equal to species, shape is equal to species plus GOM smooth, method is equal to LM plus labs. These are the labs labels, title. So, this will return the figure title, body mass and flipper length. Then subtitle, dimensions of Adelaide, chin strap and Gento penguins. Then x is equal to on x axis it is label flipper length in millimeter, y is equal to body mass in gram. So, color is equal to species, shape is equal to species. So, these things are there in the labs function. These are the labelings, and then color is equal to scale color blind. So, we get this graph. This is the title, this is the subtitle, and these are the species and these are the shapes. So, all these things are there, and this is on x lab x is equal to, so on x axis it is being typed this, on y axis it is being typed this. So, this is the complete graph and this is the complete output. Now, we can have these things through the commands also. Actually, we have to give require या library ggplot2. So, now we can run library penguins. Actually, if we run these commands from here, so it runs, and then we can run this also. See, these are the graphs, these are the outputs of this command, and see, this is without any setting, and here we have added GM points, so points are being added. Then adding aesthetics and layers. So, here we can run these commands and we are getting these data sets here, and then these three, and then we are going to run. See, we have already discussed these things. It is giving species as well as shape both. Now, we are going to have this title, subtitle, and then color, etc., and then scale color blind. So, these commands will result this graph. So, this is the graph, this is the graphic output of these commands. Now, we shall talk about visualization of distributions. Visualization of distributions. So, distribution means frequency distribution. See, just I would like to read it from here. It is better to read it from here. Visualization of distribution. Distribution means frequency distribution. A categorical variable ggplot penguins AES x is equal to species plus GOM bar. See, GOM bar, because we have not given the, we have given only one vector, that is penguin. So, GOM bar. So, this is the bar plot. But when we run this GOM histogram, a numerical variable. So, here on x axis it is body mass in gram. So, ggplot penguin AES x is equal to numerical variable body mass in gram plus GOM histogram bin width is equal to 200. So, we are getting 200 bin width. With 200 bin width, we are having a skewed distribution. If instead of this, if we make, because this ranges from 3000 to 6000. So, if we keep bin width smaller, instead of 200 just 20, see what we can get. We can get this kind of plot. So, it is not fair. Our bin width is very small, and see, these some of the bins are not having any observations, and that is why it is not showing the height of, although the shape becomes still. So, bin width with 2000, if bin width is very big, see what is the changes in the graph. See, just having 3 bins. In 3 bins it is giving, and it is not giving the good picture. So, bin width, choice of bin width and number of bins is very important in construction. Then density plot, ggplot penguins AES x is equal to body mass in gram plus GOM density. So, if we will add here GOM density, so it will give the body mass density plot. See, this is the density plot, body mass, and this is the density plot of the body mass. So, this is a very good plot, and it is right skewed. So, here it gets the real picture. Then visualizing relationship, one categorical and one numeric. ggplot penguin, first I would like to plot these things, plot these commands here on the screen. See, if we have one numerical, a categorical variable. So, here penguin A x is equal to species, it is a categorical data and GOM bar. So, when we run these commands, it is the bar plot, Adelaide frequency, then Cheney trap, and then Gen 2. So, it is a bar plot. A numerical variable here AEX x is equal to body mass. So, it is giving the histogram of body mass with bin width is equal to 200. So, it is the real. We can add here color is equal to white, color is equal to white. So, it gives the border lines white. So, we can just improve by adding these things, which we have already discussed. So, it gives a picture of right skewed, this kind of density we are expecting. Then with bin width 20, if bin width So, these are the width of the bin. At present it is 200. If we reduce it to up to 20, see what happens. See, because of very small bin width, there are some of the bins which are not having any observations. So, it is not good, it is not advisable. With bin width 2000, it is very big bin width. See, we are just having 3 categories, which is not advisable. So, here also we are not getting the good shape of the distribution. So, 200 is the best choice. So, what you have to do, it is recommended that you should go by default selection of bin width. Say for example, if we will have say control 2, say instead of 2000 we do not give anything, we are adding. See, this is the default choice of bin width. So, it is good. So, you should always keep the default choice, or we can run this and we can get the result. So, this is with bin width is equal to 20 and this is with bin width 2000. So, both are not recommended, neither 20 recommended nor 2000 is recommended, only 200 is recommended. Or you can try with practice also. Density plot, here GOM density to construct the density. So, here this is the density function, this is the non-parametric density function, then density estimator of the body mass, and which seems to be a positive skewed distribution. Then we are going to talk about visualizing relationship, one categorical and one numeric. X is equal to species, it is categorical, and y is equal to body mass in gram, it is the numeric variable. So, with that what we will get, see, one categorical and one numeric. See, here x is species, it is categorical variable on x axis, and on y axis it is body mass in gram. So, GAM box plot our geometric. So, here it is the box plot of all the 3 species. See, athlete and chin strap, they are almost having similar body mass, whereas gentos are having higher body mass. So, this is the median, this is the first quartile and this is the third quartile and this is the second quartile, and this is known as whisker. I have already defined, this is the whisker. So, here whisker is this, and these two are outlying observations. So, this is the whisker. Then we can have a density with geom density, line width is equal to, here now again x is equal to body mass in gram, color is equal to species. See, on x axis it is body mass in gram and color is equal to species. See, here color is equal to species plus geom density, line width is equal to 0.75. So, if we will write it like that, here on x axis it was species and y axis it was body mass, but here we have given x is equal to body mass and color is equal to species, and here geom density, line width is equal to 0.75. So, here this is the line width of 0.75. So, because of color is equal to species, it is having species here, and Adelaide, this is the density of Adelaide, chin strap. So, this is the density of chin strap, and this is the Gen 2, this is the density of Gen 2. So, all these three densities are being together because of the choice color is equal to species. So, it is giving, and here line width, see, just I will go there and see one categorical and one numeric variable. So, when we run, we are getting this plot. Alternatively, GM density, color is equal to species. Here Adelaide, this is a picture of Adelaide distribution. This is the picture of chin strap distribution, and this is the picture of. So, this information which is summarized in the form of box plot, they can be depicted in the form of density also, and for that color is equal to species and GM density, line width is equal to 0.75. See. So, this is the density of Adelaide, this is the density of chin strap, and this is the density of Gen 2. See here that these two, Adelaide and chin strap, they are having similar median, whereas the median of Gen 2 is much higher than these two. There is a big difference between these two. And moreover, how we can put instead of line width, say if we are having line width 1.5, see what we have the effect. See, it is a very thick line, very thick, 1.5 times. So, if we will keep it line width 1, it will give you this kind of, but if we want to keep it thinner, say for example line width is 0.5, so this is a thinner line. So, all these options are there with the density. Transparency can also be observed as transparency. Actually, transparency could be, see, alpha is the value of alpha near 0 is 100% transparent, and 1 is 100% opaque, but it is in between. So, alpha is equal to 0.5, it will give this kind of transparency. But if alpha we are going to change, see, just I would go, say here alpha is equal to 0.5. So, we are having this, these are the alpha, this is because of alpha, this. But if we will have alpha is equal to 0.2, then see what we get. See, its transparency has been decreased, transparency has been increased, it is more transparent. If it is equal to 0.01, it is almost 100% transparent. But if we will have 0.80, it is almost opaque. See, it is almost opaque. So, lower value of alpha shows 100% transparent, transparency, and higher value it lies between 0 and 1. Higher value, if it is near 1, it is opaque. It is opaque. So this is the effect of alpha. So here we have kept it at 50. See, if we are having two categorical variables, ggplot penguins AES, x is equal to island, fill is equal to species plus GOM bar, then if we have two categorical variable, it looks like this. It looks like this, GOM bar and fill is equal to species. Fill is equal to species. Here, when GOM bar without giving any position, without giving any argument here, it returns it like this. It returns it like this. But if we will have GOM bar position is equal to fill, here it gives the count. But if we will have position is equal to fill, it gives count in terms of percentage. So here add lead is fully 100%. Here chin strap is this, and here Adelaide. So it is in Dream Island, whereas Bisco, here more is Gento and less is Adelaide, and there is no chin strap. So here there is no chin strap. Here there is no chin strap. 100% here Adelaide, and here around 75% are Gento and 25% are Adelaide, and here around 50% they are on this island. There is 50% Adelaide and 50% chin strap. So it is because of position is equal to fill. Two numerical variables, ggplot penguin x is equal to flipper length in millimeter, y is equal to body mass in gram plus GOM point. So here this is the graph we have already discussed. When we have three or more variables, it is ggplot penguin AES, x is equal to flipper and body, and here color is equal to species and shape is equal to island. So this way one variable, two variable, and third variable is categorical variable, fourth variable is also. So here shape is equal to island. So we are covering four variables here, and your plot is like this. Species, so these are the species, and then island, so this is the Bisco island. So these are the Bisco island, then Dream Island, these are the Dream Island, and then Tergerson, these are the Tergerson, these squares are Tergerson. So they are everywhere. So this way we can cover three or more variables we can have, but only two are numeric, rest are categorical. Now I shall talk about, in my next lecture I shall talk about faceting of the data. Well, my dear participants, now I am going to facet the data. I am going to partition, facet, wrap, island. So ggplot penguin x is equal to flipper length in millimeter, y is equal to body mass plus GOM point AES, color is equal to species, shape is equal to species, color is equal to species, shape is equal to species, plus facet wrap island. So what it will do, because of facet wrap island, so it is Biscone island, Dream island, and Turrigan island. So it gives a better picture. So here, you know, on Biscone island, we have only Adelaide and Gento, and their range is higher up to this. Whereas in Dream Island we have only Chin Strap and Adelaide, and their range is up to here, body mass range. Whereas in Targarson Island, here it is only Adelaide, no Chin Strap, no Gento was being seen here. So this is the because of facet wrap, it could become only because of facet wrap island. So island wise faceting has been made. Saving your plots. See, we can save all these plots in a PDF file, and ggplot penguins AES x is equal to Philippa length. Say we have made this plot. Now we can save this. The function is ggsave. Ggsave file name is equal to penguin plot.png. So it will save this plot, and we can look into this plot, and similarly we can save PDF. Say I will go into, and if we will go into the file, see this is the penguin plot.png. So this is the PNG file. This is the PNG file which has been made, saved. Similarly, we can generate PDF plot also. See, this is the PDF plot.